Good morning, dear students. My name is Ferhan Mazher, and today is 7th of April 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. This is Cambridge O levels of Physics, and the code of the subject is 5054. Today, we have set our hearts to solve a theory paper. We call it paper 2, and we have selected October November 2012 2 paper. This paper belongs from the zone 2, or you can say variant 2. In this video, in this session, we are going to solve the section B of this paper. The section A of this paper we have already solved, and that has been uploaded in my YouTube channel, and in the same playlist you can find the section A video on the section A. In this video, we will be only solving the section B of this paper. So let's start this paper. So here we go. The question number 9. This is the section B of the October November 2012 2 paper. Section B showing up on your screen. Figure 9.1 shows a diver walking below the surface of a lake. The density of the water in the lake is 1000 kg per meter cube. The atmospheric pressure at the surface is 1 expo 5 Pascal, and the gravitational field strength is 10 Newton per kg. The diver inflates a balloon with air at a depth of 15 meter and attaches the balloon to a tray of objects. Calculate the pressure due to the 15 meter of the water. You can find the the pressure due to the water of 15 meter depth. The pressure of the water can be calculated. The formula is very simple. Pressure is rho gh. The formula is rho gh, and you can find that very easily. So here we go. The pressure is equal to rho gh. So the rho means the density, and that's 1000 kg per meter cube. The g is 10 Newton per kg, and the depth of the water, h here stands for the depth of the water above that point where you want to find out the pressure of the water. So that's 15 meters. So 1000 multiply 10 multiply 15, and that will be 150,000 Pascal. So it will be 1.5 expo 5 Pascal. So that's our answer. So let's look at the marking scheme. 1.5 expo 5 Pascal is the right answer, sir. So our answer is right. Okay, so the next question is the total pressure at 15 meter below the surface of the lake. Below the surface, 15 meter below the surface of the lake, the total pressure will be the pressure of the water plus the atmospheric pressure. So just add the atmospheric pressure and the pressure due to the water. So the total pressure will be pressure of the water plus the pressure of the atmosphere. It will be 1.5 expo 5 Pascal plus 1 expo 5 Pascal, and it will become 2.5 expo 5 Pascal. So let's have a look at the marking scheme, check whether if our answer is right, because it's possible, being a human, so it's possible that we make some mistake by in writing or when we are doing the calculation. So it's always recommended that you confirm your answers from the marking scheme. Okay, so we are done with that part. The air in the balloon occupies a volume of 0.048 meter cube at the pressure calculated in the A second part. The diver releases the tray and the balloon, and they begin to rise. The temperature of the air in the balloon does not change. Calculate the volume occupied by the air in the balloon at the atmospheric pressure. So P1 is 2.5 expo 5 Pascal, and the volume 1 is 0.048 meter cube. And when the balloon will be under the subject of only the atmospheric pressure, so the P2 will be 1 expo 5 Pascal. What will be the volume of the balloon at that moment? So V2 is the question. Okay. So Uh, Here we go. So the P1 V1 equals to P2 V2. The P1 is 2.5 x per 5 Pascal. V1 is 0.048 meter cube. P2 is 1 x per 5, only the atmospheric pressure. And the V2, what will be the volume of the balloon or air at that moment? So V2 will be equals to 2.5 x per 5 multiplied 0.048 divided by 1 x per 5 equals to, and that will be 0.12 meter cube. So 0.12 meter cube is our answer. So let's have a look at 0.12 meter cube is the right answer, sir. Okay, so we are going to next part. The pressure of the air inside the balloon is less at the surface than at a depth of 15 meter. Explain in terms of the air molecules inside the balloon why the pressure is less. You see, when you are at a depth of 15, the balloon is at the depth of 15 meter. The volume of the balloon is small, less. So the volume of the air is also small. So, but when the balloon comes to the surface of the lake, the volume of the balloon becomes larger, and obviously the air inside the balloon, its volume also increases. So when that volume increases, you see what happens. The number of molecules per unit volume decreases because the volume has increased. The mass of the air has not increased. The number of molecules has not increased, but the number of molecules per unit volume, that has decreased. And the distance between the molecules has increased when the balloon is at the surface, because the balloon will become larger. So the distance between the air molecules inside the balloon has increased. The number of molecules per unit volume has decreased. Their collision frequency with the walls of the balloon has decreased. So that's why the pressure of the air in the balloon, when it will reach the surface of the lake, that will decrease. At the surface, volume of the air becomes larger, molecule per unit volume of the air decreases, collision frequency of the air molecules with the walls of the balloon decreases. This is my answer. So let's have a look at the marking scheme. It's a 3 marks question. So looking at the marking scheme is very important here. Molecules, particles further apart, and their speed is unchanged. Remember, the temperature has not changed. It means their speed has not changed. It means their kinetic energy has not changed. Molecular collisions with the balloon wall and unit area, that will decrease. Less frequent collisions, not if the force or the violence of each collision, less. Okay. So our answer looks right. Okay, so let's move to the next part. He says, state one difference between the arrangement of the molecules of the water in the lake and the molecules of the air in the balloon. Basically, he's asking you to write the difference of the arrangement of the molecules in the liquid and in the gas form. So in the gas form, the molecules are far apart from each other, and in the liquid form, the distance between the molecules is relatively smaller. In the gas form, the molecules move individually, randomly, in all directions, and they occupy whatever the container you have provided them. They will occupy the volume of that container. But in the case of the liquid, the molecules move around in the form of clusters, and they cannot occupy the all volume of the container. The volume is fixed of the liquid. So it's not necessary that it will occupy all the volume of the container. So let me show you my written answer, then we will have a look at the marking scheme. The molecules of the water move in clusters and remain in the body of the liquid. Air molecules move individually and randomly. The distance between the air molecules is larger. Okay, remember these words. Okay, so water molecules are closer, move in clusters, move within the liquid. Or air molecules far or further apart, move individually, move throughout the container. So you can write a better answer, I hope. I've just given you an idea that what should be the answer. Okay, question number, the next part is D. When the diver release When the diver releases the tray, the balloon accelerates upward and reaches a constant speed before it arrives at the surface. So they are talking about the balloon coming towards the surface of the lake. So the balloon is moving in the water. Explain how the forces acting on the balloon cause it to behave in this way. You see, when the balloon will be moving upward, it's coming upward because of the upthrust of the water. The water applies force on the objects in the upward direction. We call it the buoyancy, or we also call it the upthrust of the water. So that upthrust is acting upward. The weight of the balloon is acting downward, and another force which is in the downward direction will be the drag of the water, the friction of the water, because the balloon is moving upward. So the drag will is opposite to the direction of the motion. The balloon is coming upward, so the direction of the drag will be downward. So at the start, the balloon is moving not with the very large speed. So what will happen? The Because the balloon, as it starts moving upward, its speed will increase, and when its speed will increase, the air resistance, the water drag will increase, and the water drag eventually will become equals to the upward, the upthrust of the water, and that will be balanced. And when the forces upward and downward forces will be balanced, the resultant force will become zero, and the balloon will start moving with a constant speed. So let's have a look at my answer, and then we will clear it more from the marking scheme. Upthrust of the water is larger than the downward forces of weight and the water drag. Resultant force is in the upward direction due to increase in the speed, because the resultant force will be in the upward direction. The speed of the balloon will increase. So when the speed of the balloon will increase, the due to increase in the speed, the water drag becomes equals to the upthrust of the water. Resultant force becomes zero. So when the resultant force will become zero, the balloon will start moving with a constant speed. So let's have a look at the marking scheme. Net resultant unbalanced force is upward at first, or upward force is greater, and the friction, resistance, drag, downward force increases until the downward force becomes equal to the upward force. Force is balanced, and there will be no resultant force. So I think we have written our answer in the same lines. So let's move to the next part. Next question is, he says, on the axis in figure 9.2, sketch the distance time graph for the balloon as it travels 15 meter to the surface. So it's a distance time graph, and the slope of the distance time graph represents the speed. So the speed of the balloon will, at the first, it will be zero, obviously, and then it will increase. And because the speed will be increasing, so the distance time graph's gradient should increase, and eventually what will happen, the speed will become constant. Then the distance time graph will be a straight line. Okay, so here we go. So here you can see I have made a increasing curve, and then this is a straight line up till you reach the 15 meter. So let's have a look at the marking scheme. Start from the mark 0, 0, or initial gradient equals to 0. Increasing gradient initially, constant gradient must be greater than 0 finally. So our answer is right, sir. So we are done with the question number 9. So let's move to the next question. The next question is question number 10. A laser produces red light of the frequency 4.7 expo 14 hertz. The speed of the light in the glass is 2 expo 8 meter per second. Calculate the wavelength in the glass of the light from this laser. V equals to F lambda, and we know the things, and we can very easily find out the value of the lambda. So let me show you. Here we go. So V is equals to F lambda. V is 2 expo 8, and the F is 4.7 expo 14 hertz. So lambda will be equals to 2 expo 8 divided by 4.7 expo 14 equals to and the answer will be 4.3 expo minus 7 meter. So let's check the answer. 4.3 expo minus 7 meter. 4.3 expo minus 7 meter is the right answer, sir. So let's move to the next part. He says, describe an experiment to verify the law of reflection of light. You may include a diagram in your answer. So it's a 5 marks question. So very important. Try to understand this question. It carries huge marks. So we will take a white paper and we will fix that white paper on a drawing board. And then with the help of a scale, I will draw a straight line AB. And then I will find the midpoint of that AB line, and I will say that is, let's say, M. And then at the point M, I will draw perpendicular to the AB line. I will call it normal. Then I will draw on the to the left side of the normal at the point of incidence. I will draw a line which will make an acute angle with the normal. And then on that line, I will put 2 pins, pin 1 and pin 2, which are 5 centimeter apart. And then I will take a plane mirror and I will place that plane mirror on the AB. And then I will go to the right side of the normal and I will look into the glass and I will look for the image of the pin 1 and the pin 2. And by looking through the glass, through the mirror, plane mirror, I will place on the right side of the normal 2 pins, pin 3 and pin 4, in such a way that the pin 3 and the pin 4, they are aligned with the image of the P1 and P2. Then I will mark the position of the pin 3 and the pin 4. And then I will remove everything. I will join the pin 3 and the pin 4 position with the M with the straight line. Then with the help of a protractor, I will measure the angle of incidence. That's the between the incident ray and the normal. And I will check the angle of reflection. And that is the angle between the reflected ray and the normal. So I will find that angle of incidence is equals to the angle of reflection, and that is the law of reflection of the light. So I hope you have understood my description. So now let me show you my written answer. So mark a straight line AB on a paper. Mark M, the midpoint of the AB. Draw normal at the M to the AB. Draw a line CM which makes an acute angle with the normal. Place pin 1 and pin 2 on the line CM. Place a plane mirror on the AB. From the right side of the normal, look into the mirror. Place pin 3 and pin 4 in such a way that the pin 3, pin 4, and the image of the P2 and the pin number 1 are aligned. Join the pin 3 position and the pin 4. So join pin 3 and pin 4 mark with the M. Measure the angle of incidence and the angle of reflection with the protector. So you will observe that the angle of incidence and the angle of reflection, they both are equal to each other. So this is my written answer. So now let's look at the marking scheme, what the marking scheme has to say. He says you can use a ray box for the light source, laser and mirror, and pins and mirrors can also be used. Shine the ray at the mirror marks grace, measure angle of incidence and angle of reflection, and they will be equal. For pins, he says pins and mirror, place 2 pins, 2 more pins in the line with the image, measure I and R, and are equal and repeat. So I have not written that repeat thing because the lines were over. But remember, here we have it carries 1 mark. So at the end of your answer, write repeat. Okay. So question number 10, and it's C part. He says the figure 10.1 shows a ray of light traveling in an optical fiber. The ray strikes the side of the fiber at the P. The angle between the ray and the side of the fiber is 7. So their question is determine the angle of incidence of the ray at the P. You see angle of incidence, draw a normal here. So that normal makes 90-degree angle with the surface. This angle is 7. So this angle with the normal will be 90 minus 7 and it will be 83. Here you can see determine the angle of incidence of the ray at the P, and that will be 90 minus 7, that will be 83. So let's have a look at the marking scheme. 83 is the right answer, sir. Okay, the next thing, state and explain what happens to the ray at the P. So ray at the P do not come out into the air, but here the angle of incidence is more in the dense medium is more than the critical angle. So the process of total internal reflection takes place and the light is reflected here. So that is the question. It's a 2 marks question. So let's have a look at my answer. So the angle of incidence in the dense medium is greater than the critical angle of the optical fiber. The total internal reflection will take place at the P. So this is a total internal reflection. Total internal reflection. Angle of incidence exceeds critical angle. Okay, so the marks. We have written that angle of incidence. Okay, so the next part is coming up on your screen. He says, a room is illuminated by wall lamps. Okay. Figure 10.2 shows a mirror in the wall behind one of the lamps. X is a point on the filament of the lamp. It is 0.19 meter in front of the mirror. On the figure 10.2, draw rays from X and locate the image of X. Label the image I. It's a 3 marks question. State the distance between the eye and the mirror. Okay, so let me show you my answer. Very simple. You see, the method is very simple. You can see this distance with the help of the scale measure. What is this distance? Go behind the mirror the same distance on the same line. So you will have this point. Then select where is your observer. For example, you suggest that your observer is here. Your observer can be here. But I selected that the observer is here. So join it with this point. Okay. This point is on the same line and the same distance behind the mirror. And join this with the observer where this will be the angle of incidence, this will be the angle of reflection, and you will see that they are automatically equal. Here the image is seen by this observer. So call this point I. He says at least one ray from X to the mirror, at least two rays from X to the mirror, and correct reflection rays traced back to the mark I, or I marked in correct place by I. Okay. So the next part they asked is state the distance between I and the mirror, the distance between the I and the mirror. You see the object is 0.19 meter in front of the mirror. So the image of this will be also 0.19 meter behind the mirror. That's the simple rule. Okay. Now, he says, suggest one advantage of placing a mirror behind the lamp in the room. You see, you always find, for example, if you look at the headlights of your car, you will observe that behind that lamp, filament lamp, there they have placed mirrors. So the light is reflected, and same way, if we place a lamp in the room, at the wall we put a mirror. So the light which goes towards the wall from the mirror, it is reflected and come back into the room, and the room will be more illuminated. So the light from the lamp which went towards the wall is reflected back into the room. Room will be brighter. Okay, so let's have a look at the marking scheme. It says, so less or no light is wasted, or how the hall becomes brighter. So we are done with the question number 10. We are going to the next question. A wire is wound around a soft iron core forming a solenoid, as shown. There is a gap in the core. The solenoid is connected in series with a 12-volt battery and a variable resistor rheostat. The resistance of the solenoid is 0.30 ohm, and the variable resistor is set so that it has a resistance of 4.5 ohm. Calculate the current in the solenoid. You know we know the EMF of the battery and how much current is coming from the battery, that we can found easily. The current from the battery is equals to the EMF of the battery divided by the total resistance of the circuit. We know the resistance of the circuit. We can just add these two resistors. So it's a 3 marks numerical. Let me show you my solution. Here we go. So the current coming from the battery is equals to the EMF divided by the R equivalent, the total resistance of the circuit. And the EMF is 12 volt, and the total resistance of the circuit will be, 4.8 ohm. So 12 divided by 4.8 ohm, that will be 2.5 ampere. So 2.5 ampere will be coming from the battery. So 2.5 ampere is the right answer, sir. The current in the solenoid magnetizes the soft iron core. Explain how the electric circuit is used to increase the strength of the magnetic field. You see, if you want to increase the strength of this magnetic field, there are 2, 3 methods which you can do. You can increase the voltage here by putting more cells in series with this battery, or a very simple method is decrease the resistance of this battery, this variable resistor. When you will decrease the resistance of this variable resistor, the current coming from the battery will increase, and more the current flowing through these wires, the stronger will be the magnet. So let me show you my written answer. Here we go. The current in the solenoid magnetizes the soft iron core. Explain how the electric circuit is used to increase the strength of the magnetic field. He says decrease the resistance of the variable resistor. Current from the battery will increase. The strength of the magnetic field will also increase. Okay. So decrease the resistance of the variable resistor. So the current from the battery will increase. This will increase the strength of the magnetic field. Here I have missed the word increase. So hope you understand. So let's have a look at the marking scheme. He says decrease the resistance of the variable resistor and increase the current in the solenoid. Okay, so let's move to the next part. Figure 11.2 shows a horizontal current carrying wire PQ in the gap. The magnetic field in the gap is uniform and is vertically upward. So the magnetic field is going from bottom to top, it's going upward. The current in the PQ is from the left to the right. Describe the effect of the magnetic field on the PQ. You see, because the PQ is a current carrying conductor placed in the magnetic field, so it will experience motor effect and it will move. So the wire PQ will experience a force out of the page. And how do I know this is out of the page? I have applied the left-hand rule. And from the left-hand rule, I'm able to tell that in which direction it will move. So let's first have the force on the PQ wire, or the PQ wire moves, force movement out of the page, outwards towards observer, not upwards. Okay, you are not supposed to say it will go to the top of the page. So the next part is state the effect on the PQ if increasing the strength of the magnetic field in the gap. You see, if you make this magnetic field stronger, the force exerted on the PQ will also become stronger, and the PQ will move faster and quickly. So the force on the PQ will increase and the PQ will move faster. That is my answer. Hopefully you understand. Okay, so you can look at the marking scheme. I have already checked it. The starter motor in a car is powered by a 12-volt battery that is positioned next to the motor. The current in the motor is 75 ampere. Calculate the power supplied by the battery. You know the power is equals to IV. The power is equals to IV, and both the I and V we know, so we can easily find the power. So power is equals to IV. I is 75 ampere and V is 12 volt. So 900 watt. 900 watt is the answer. Okay, so the next question, the next part. But first of all, let's have a 900 watt is the right answer, sir. Now, it says, suggest and explain why the wires that connect the motor to the battery are very thick. You see, through these wires, the 75 ampere current is flowing. And when the current flows through a wire, the electric energy converts into heat, and due to the resistance of the wires, and that is the power loss because the energy is being converted into the heat, and that is being absorbed by the atmosphere, so it's a loss of energy. So that wire should be thick so that its resistance is low and less heat is lost to the surrounding, less energy or power is lost to the surrounding. Thick wires have and the important thing is the thick wire has low resistance. Their resistance is very low, so the heat produced due to the flow of the current will be less. Yeah, that's the right answer, sir. Because the thick wires have low resistance. Thick wires have low resistance. Thick wires not as hot and do not melt. A relay is used to switch on a starter motor in a car. Describe how the relay works. You may include a diagram in your answer. It's a three number marks, and it will be the last part of this paper. So what we will do, let me show you. Here we have. Here I have shown a relay, and this relay is connected with the switch, and there's a battery. The amount of the current and the voltage in this switch in this relay is very small. So in the circuit number one, we have a relay, a solenoid. So when you close this switch, what happens? You know, when you close this switch, what happens? The current flow through this solenoid, and this solenoid becomes electromagnet. When this becomes electromagnet, it attracts the vertical portion of this iron armature. So this vertical portion will move towards the left. So due to this pivot, this horizontal portion of that iron armature will move upward. When it will move upward, this will uplift this lower contact, so that this lower contact will come in contact with the upper contact, and the path of the electricity in the circuit number two, where you have the starter motor, will be completed. So in this way, you are able to switch on and switch off circuit number two, and the switch which you are using is in the circuit number one, and it has a very small amount of current and a very small amount of voltage. So that's the benefit of using a relay. So in the circuit number one, as is closed, the solenoid will become electromagnet. The vertical iron armature is attracted to the left. Horizontal iron armature will move upward. It will uplift the contact, that lower contact in the diagram you can see. So both the contacts touch each other. The current will start flowing in the circuit number two, where you have your starter motor. So he says the current to the relay coil solenoid electromagnet core relay coil solenoid electromagnet magnetized connections made in motor circuit. Okay, so we have shown all these. So my dear students, we have done today October, November 2001 2, and it's section B. In this video, I have tried my best to explain you the concepts, try to make the measurements and the calculations clear to you. If you think that this video is helpful to you, kindly, if you are watching this video, kindly subscribe my channel and also like this video. Also send me your comments And because when we are making videos, I may make a mistake. To make a mistake is human. So to err is human. And if you find any mistake in my paper, kindly let me know, and then I will try to highlight that mistake. So thank you very much, everyone who is watching this video. Please share the link of this video onto your Facebook account and onto your Instagram accounts and onto your Twitter accounts. And also share the link of this video with your friends, with your class fellows, especially with your junior students. So thank you very much, everyone. It's a great blessing for me to teach you online and to be helpful to so many people around the globe. And this is, you can say, the teaching of physics without borders, beyond the borders. So thank you very much. It's a blessing for me. Thank you very much, everyone. Have a good day. God bless you.